Welcome to On Cloud, the podcast for cloud professionals, where we break down the state of cloud computing today and how you can unleash the power of cloud for your enterprise. Now, here's your host, David Linthicum.
Welcome back to the On Cloud podcast. Today on the show, I'm joined by Dennis Gatens, founder and CEO of LEOcloud. How you doing, Dennis?
Doing well. It's been a great, productive week. Just feeling really good about the direction and pace at which LEOcloud is progressing.
Yeah, and it's a new learning experience for me. I think we're going to talk about things that I know about, but a lot of the things you talk about, I don't know anything about. And that is really kind of compute in space, cloud in space. And, your listeners have asked for some new and interesting topics. It doesn't get much more new and interesting than this. Give us your story, introduction to you, how you got to LEOcloud, what you've been doing in the past, things like that.
Yeah, happy to. So I started out as graduated from Virginia Tech EE and stepped right into some really interesting technology-driven leading-edge engineering projects. And it really became sort of a common thread throughout my career of emerging technologies into emerging markets, delivering complex solutions into a range of market segments or environments, from avionics to space to commercial communication service providers, cloud service providers. So it's really been an exciting ride. Along the way, I started out as an engineer, always found myself thinking more about the big picture of the strategy, transition from product management into marketing, strategic sales, channel partner management, BU leadership. So I really acquired a pretty broad experience base and set of tools that set me up naturally to step into launching a company at a point in time which really was nicely aligned with an emerging market, which is commercial space.
So tell us about LEOcloud.
So LEOcloud, the genesis for it was as I began to see the commercial space economy evolving in a way that it was, where the communications infrastructure was beginning to move closer to the terrestrial technologies and capabilities and more into building out network strategies, and even to the point of becoming an IP infrastructure. That's the direction it was taking. It became clear that in order for the economy in space to really meet its potential and realize its potential, the communications and cloud infrastructure were going to have to evolve into space. And so I took it from there and focused on how do you bring this to market. And I focused on the value proposition of edge computing. If you think of space, it's sort of the ultimate edge. And in the value proposition, it really has tremendous value and benefit in space, particularly as humans move further away from Earth, LEO, the lunar region of the moon, and then beyond Mars. I mean, all plans that are right in front of us and being worked on. So it started there. And the fundamental benefit being that you move the resources, the compute, the cloud services as close as possible to the sources and users of data. Well, that certainly applies in space. And so from there, I thought about it as, well, there's a lot of point products. There's a lot of single board computers, multi-generations of them, a lot of them, some rad hardened to deal with the harsh environment, some commercial repackaged that really present a reliability and availability challenge. So I thought about, how do you deliver this to an operator of a spacecraft or a constellation when it's pretty far from their subject matter expertise, whether they're building communications infrastructure or imaging satellites or building commercial space stations. So bring them a managed service that enables the cloud services that exist on Earth to be extended into space, and scale it from satellites where there's very low power available, very low power budget, very small volume, and very harsh environment, and scale it from there to a relatively large volume of a commercial space station, or what we envision eventually orbiting data centers in LEO and the lunar region around the moon. So that became the strategy, a managed service of basically a managed infrastructure as a service that extended cloud services as we use them today in a ubiquitous way into space.
Yeah, and people are listening to this and they go, cloud in space, we don't get that. The reality is you're putting a infrastructure in space, storage, compute, things like that, which is closer to where you're gathering the data. And as we're launching commercial uses of space, and all you have to do is look at the headline news with all the companies out there, not just the government that's getting into this space. The ability to process information and have compute capability is something that's going to be an exploding need, at least the way I see it. So tell us about the growth of space, where the economy's going, and, really, what you see is the use case for this in the next few years.
There's a fairly strong consensus around it being $1 trillion market within a decade. And we seem to be on that trajectory from if you look at the value chain of a space economy, from the launch services and the range of launch services, from heavy lifts to relatively small lifts, of small satellites to large satellites, the emergence of commercial space stations that eventually will replace the International Space Station. It's all moving forward, and the use cases for whether it's running an operation in space that might provide a commercial service, or provide have military or government applications, or R&D. There's a clear demand for having a presence in space, both man and machine. And that's just LEO. You go to the lunar region, the same. There's a lot of focus and an effort in establishing an industrial base and a government military presence in the lunar region, including on the surface of the moon. So the value chain is evolving rapidly. The cost is coming down. It's still high. For example, taking R&D up to space station today, it's pretty expensive, but there's clearly a benefit to cost associated with it. After 10 years of the ISS National Lab being available, for example, there's been at least $1 billion of venture funds flowing into companies.
International Space Station.
Yes,
is that
the
right?
International Space Station, or ISS. But there's been over $1 billion of venture funding flow into startups that did basic research on ISS. So and the demand for those resources today, the ISS National Lab facilities, which is an allocated portion of the ISS, outstrips the availability of resources. So there's clearly a market being incubated just in the R&D space for the next generation of commercial space stations.
So why can't I just take a commoditized cloud server and stuff it into a spacecraft and shoot it off into space and just have it function in space?
You can. You need to cross your fingers, cross your toes, and because it comes down to resiliency, reliability, and availability. Whether it's a pressurized environment or a non-pressurized environment, pressurized being inside a space station where it's human rated, non-pressurized being bolted onto a satellite bus. Harsh environments, the ride is a rough ride getting there. And if you're going to rely on these capabilities, it will fail when you really need it. And that's a bad scenario on Earth. When we lose one of our services, it could be a very dangerous situation in space. So I'm going to circle back a bit. And that's why we look at it from, you can't fly COTS, you can't repackage COTS. It will not have a predictable, useful life. So we're building our system from literally the silicon layer up as a space-hardened platform that has a lot of design and analysis that will predict with high confidence a useful life of 10 years. In addition, it has layers of resiliency and health monitoring built in so that we can allocate resources offline before they might become an issue. So it really comes down to, you have to build the platform for the environment, which is pretty, that's a pretty basic requirement for any development of a product. And what we like to say is you can't roll a truck in space. On Earth, we roll trucks to service equipment in small businesses, large enterprises, data centers. Can't do it in space. So that really comes down to that. And our customers talk about availability. They want to hear about the resiliency. They want to hear about the rad hardening techniques and analysis that goes into resulting in a predicted life for a platform.
Yeah, I think it's the mother of all capabilities or trust. If you're going to put something into space for 10 years, it has to be in a way that's going to function. If you can't go into a data center and replace it like we can right now. So it's got to be kind of a different level of play in terms of reliability, in terms of durability, in terms of the ability to have remote management capabilities, ability to have self-healing capabilities. So let's talk about the use cases for space. So why are we doing this?
Yeah, so all the above to what you just said, 100%. So we look at use cases in two fundamental groups. One is R&D. I mentioned it briefly. And the second is a range of operations, data analytics, AI-based analytics, and AI-based autonomous operations. So let's start with R&D. So I mentioned the International Space Station National Laboratory that has been in existence for 10 years and provides research facilities in a microgravity environment. Microgravity environment has real value for certain types of research, everything from manufacturing fiber that is purer than what we can manufacture on Earth. The range of use cases or types of research range from biomed to cancer treatments, tissue engineering. I mentioned fiber pharma, crystal development, 3D printing, semiconductor development. All these types areas of research are taking place in space today and have been taking place on the International Space Station for 10 years now, both inside the facility where it makes sense, and then outside the facility on what are called R&D platforms that are bolted onto the space station where they can deliver materials for example, for understanding the impact of the environment on whatever the material might be, and then bring the results back. What's become a very common requirement and has not been fulfilled yet is the need for local compute and data storage. So, and thus we're addressing it with the next generation commercial space station players. So there's a broad range of R&D. I mentioned the venture funding that has flowed into startups, the users, commercial, government, some military, and universities. So there's a lot of basic research that's taking place today in space, taking advantage of the microgravity environment. And that environment will also have benefit to manufacturing as well. And the fact that you can be manufacturing in space enables you to have waypoints for manufacturing as we go deeper into space as well.
What changes when supporting a storage system in space, whether that's in the aircraft or outside the aircraft? You zero gravity, obviously the environment's different and went through a rough ride to get there. But what is better for the device and what's worse for the device in terms of its existing in space or on a spacecraft?
Well, there's a number of considerations. There's thermal cycling that occurs that you have to manage. There's the power budget that you have to manage. So there's relatively limited power resources in space. So you have to design highly efficient, power managed platforms. And then there's the radiation dosage, the understanding of what the electronics will tolerate, predicting it through analysis, and then design implementation, predicting to what extent it will survive in that environment and to what length of time. You have to have systems in place to recover from single event latch-ups, for example. You have to have completely autonomous capabilities to diagnose a platform, restart it, decommission resources, whether it's processing or memory, so that the platform continues to operate. And so one of the things, for example, is you have margins, you have memory margins. You spec a certain level of memory, but in reality, there's 1.x memory available so that you can anticipate some loss of memory over time. These are all the considerations that have to be taken into the design requirements and design analysis and testing. In terms of advantages, it's hard to really place any real advantage that a piece of electronics can realize running in the harsh environment. It's more about adopting it to survive and perform in the environment.
So where is this going? Let's talk about the future of cloud and space. As we're starting to, obviously, computers are not new to space. We've had forms of computing and, more primitive kinds of things that we've supported over the years. Now we're going to have more up there, and we're going to have more use of these particular systems and the ability to kind of support compute and storage in kind of a more traditional way, since things we're doing it very much like we do it on premise, but doing so with different equipment. Where's this stuff going? Where should we kind of watch the industry mature over time?
There's multiple segments to watch. I'll speak to it from how we segment the market. Satellite data suppliers, they develop a tremendous amount of raw data. All comes back to Earth. Takes time, takes a lot of time, costs a lot of money. There's security issues once it lands on Earth. You can, if you move the compute onto the satellite, which is going to intersect their roadmaps here in the near future, you can now process the data and deliver your product from space, your imaging product, standard product offering. And you can also allow your customers to run their applications or workloads in space so that they're getting the results directly from the satellite, directly to the user. Real advantage, real cost advantage, real advantage in latency. You're upselling to your customer. Commercial space stations, you will begin to see first launches as early as 25, more likely 26 and 27. They're already developing their funnel for customers, particularly in the R&D area. So you'll begin to see the emergence of the commercial space stations that will eventually replace the ISS. And they all see the need for on-prem compute that is offered. They can offer to their customers as a service. So we deliver that capability for them. R&D platforms. R&D platforms today collect a lot of data. When I say an R&D platform, I'm referring to a platform that's attached to the ISS today that's external, where a lot of research takes place. There's no compute resources there. All the data has to be delivered back to Earth via relatively slow communications channels you have to have your time scheduled on it. So it really inhibits the delivery of data back to Earth. Some data from station comes back on memory sticks. Yeah, that's where they're at today. So moving the resources onto these platforms enables, again, the customer to have in-situation or local compute to iterate with the data with their research. And this saves time. Time is money when it comes to research in space, very expensive. We anticipate it in the next few years as well. And then the lunar region. The lunar region is just an amazing concept of one, establishing a presence 50 plus years later, but two, the concept that the value and necessity of local compute is even greater, the further away you are from Earth. So we envision that market segment to evolve or begin to exist within a couple of years. And we're really excited because we have ongoing activity and beginning to develop delivery commitments very quickly, very soon, into those market segments.
Yeah, it's funny. I think that as cloud pros, we're kind of used to free networking. In other words, it's almost free. It's very fast, very low latency, and therefore it's not a problem to ship huge imaging files and huge other binary files across to do the analysis locally. But that's not an option. So that's kind of, to me, kind of the killer application. So if you're going to leverage these systems to provide satellite imaging and you're on the satellite, your ability to process it at the time when you obtain the image, when you obtain the data, is going to be a huge performance advantage over shipping things back to Earth, which I think, do we do that today, or do we do a lot of processing of images at the source within the satellites?
No, it's all raw data coming back to Earth. And what's really sort of a throwback is that you have to fly over a ground station, and they do it on a routine basis, and you get 15-minute window of downloads. If you don't download all the data, you wait till you have the next flyover at the next ground station. That's a level of latency that many of us here on Earth have never experienced. It's akin to the mail, but there's tremendous advantages of eliminating what we call the inside the terrestrial loop of compute on Earth and moving it into space.
Yeah, the fact you're focusing this at a particular set of use cases, there's a need for it. It's architectural reality in terms of how it's able to communicate. Latency, reliability, durability of these various systems. So I think it's a huge growing space right now. It's kind of exciting if you think about it. The ability to, in essence, put edge-based systems at space and have the capabilities there that you wouldn't have if you're shipping everything back to Earth. And you're not going to be able to ship everything back to Earth. So you're able to do things faster, absorb more data, make decisions based on the data, even have AI-based knowledge-based processing the data at the point. Is that kind of the vision?
Absolutely. Yeah. The deep data fusion capability of cloud and space has tremendous advantage. And the most notably, within Space Force. For them, it's all about gaining a warfighter advantage. So if you can process the data in space that you're collecting in space, many, for example, imaging and sensing and monitoring, and running the analytics and then delivering the results directly to the end user, person in need, that's a tremendous advantage. Particularly, you eliminate the latency of coming back to Earth. So inside the terrestrial loop concept, you strengthen the security around the delivery of the results, and you reduce the cost. So there's a real advantage of this architecture that we believe is going to evolve, having the underpinning of communications infrastructure that's evolving, where satellites can bring data, relay data back to a orbiting data center. And that orbiting data center can collect data from many sources in space. Think of a cell tower on an orbiting data center, providing communications access from many sources, many constellations. You now have the ability to collect all the data in space, fuse it, deliver the results without any of it touching Earth.
So where can we find more about yourself, more about LEOcloud, and also where can we learn more about how this technology is evolving?
Well, so I try to maintain a presence on LinkedIn. I think LinkedIn is a great tool for communicating and conveying information. I have the opportunity to speak at a number of conferences routinely through the year. There is no web presence for LEOcloud. We are just a startup. So it's really whoever wants to have a conversation with me. I'm on LinkedIn, or just message me or follow, and we'll start a dialogue.
It's exciting stuff. I mean, this is, if you think about it, there's a great use case for this. There's a growth in the market and our ability to understand how to do this stuff in a reliable way. It's just kind of taking edge computing to the next level. You have to plan for something that's going to be in place and in production for many, many years. And we're not used to that now. Or you can always drive out to a remote site and things like that. Can't do that with these things. So if you enjoyed this podcast, make sure to like us, rate us. You can also check out our past episodes, including those hosted by my good friend Mike Cavas. Find out more at LeOcloudPodcast.com. All one word. If you'd like to contact me directly, you can email me at davidlinthicum, dlinthicum, LINTHICUM, @Deloitte.com. So until next time, best of luck with your cloud journey. You guys stay safe. Cheers. Bye.
Thank you for listening to On Cloud for Cloud Professionals with David Linthicum. Connect with David on Twitter and LinkedIn. And visit the Deloitte on Cloud blog at Deloitte.com/US/Deloitte-on-cloud-blog. Be sure to rate and review the show on your favorite podcast app. This podcast is produced by Deloitte. The views and opinions expressed by podcast speakers and guests are solely their own and do not reflect the opinions of Deloitte. This podcast provides general information only and is not intended to constitute advice or services of any kind. For additional information about Deloitte, go to Deloitte.com/about.